Hello everyone, I just wanted to give you some notes on ionic bonding. First, we're just going to start talking about ions in general. So ion are atoms with an electric charge due to the loss or gain of one or more electrons. Hopefully you've already done that in your textbook note and assignment reading. Alright, so hopefully you have your periodic table in front of you, and what I want to show you is and talk about valence electrons. So valence electrons are those electrons that are in the outermost shell, and the electrons, the valence electrons, are what make reactions happen. It's why elements act the way they do. Okay, so I want to make sure that you're able to put some stuff on your periodic table. So for example, group 1 is right here. This is group 1, right? Because groups go up and down. And everything in group 1 has one valence electron. Everything in group 2 has two valence electrons. Then everything right here in these transitional metals, we skip those because they have different amounts of valence electrons depending on which one they are. They don't really follow the good rules. So we're going to skip over here to this group, group 13. And group 13 has 3 valence electrons and then 4 valence electrons. And it just kind of keeps going, 5, 6, 7. And the noble gases have 8 valence electrons. That's what makes a noble gas not react with anything, is because they are already full. Every element wants to be like the noble gases. They want to have 8 valence electrons because 8 is a full energy level. So how this works for ions, let me extend the page here. So I'm going to use like lithium, for example. So lithium is number 3, so it has 3 protons and it has 3 electrons because protons and electron number have to cancel out. So of those 3 electrons though, one of them is a valence electron because it's in group number 1. So in order for it to be like a noble gas, it wants to be like a noble gas, and the number 3 lithium is in between helium, which is number 2, and neon, which is number 10. Lithium is closest to helium because 3 is closer to 2 than 10, so it's going to give away that 1 valence electron. It really wants to give that away. So that 1 valence electron is given away, and now we have this extra plus 1, and that is why lithium and everything in the group 1 column has a plus 1 charge, okay? And it's a little bit weird in that first energy level only has 2. Helium and hydrogen are weird in that they only have 2 valence electrons, not 8, but they're just a little bit weird. All the other noble gases have 8. It's called the octet rule. Okay, now for example, again, let's use maybe magnesium over here for number 2, for my group number 2, just for another example. Then we have magnesium. Magnesium has 12, 8, 9, 10, 11, 12. It has 12, and it has 12 electrons. And of those 12 electrons, 2 of them are the valence electrons. So if I scroll back up, what is it going to do with those 2 electrons? Well, it's closer to neon, which is number 10, than argon, number 18, because magnesium is number 10, or number 12, right? And 12 is closer to 10. So in order for it to be like neon, the noble gas, because everything wants to be like noble gas, it's going to give those 2 valence electrons away, and now we have a positive 2 charge. Okay? So that's the number of valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. All of these ones over here already have 8 valence electrons, so they're going to have a charge of 0. So let's put these charges as well into our periodic table. So make sure that you have this number written down that we just wrote down, because that's the number of valence electrons for each group. Okay. Now above that, and maybe in a different color, I'm going to write the ion charges. So because of these valence electrons, each group has a certain set of charges as well. So this first group, because they have 1 valence electron, they have a plus 1 charge. My plus doesn't look very good. Group number 2 has a plus 2 charge. Then we skip, because remember these transition metals are weird. We're going to skip these ones. This group over here has a plus 3 because it's going to get rid of those 3 extra electrons. Now, this group number 4 right here, it's a little bit weird because remember we're thinking about They want to be like a noble gas. And so that outermost energy level has to fill up to 8, or it has to empty out completely so that the next energy level is full. So here this 4 is 4 closer to 0 or 8, and it's actually in between. So this one is a little bit weird in that they can have a positive or a negative 4 for their ions. Now this next group with nitrogen, 5 is closer to 8. So instead of losing any electrons, they're going to actually take electrons. So for example, I'll do an example here with nitrogen. Nitrogen has 7 protons and 7 electrons. Okay? It only has 5 valence electrons though. It really wants to be like the noble gas is. It's really close to being like neon, which only needs to gain 3 electrons to be like neon, because neon is number 10. So it's going to gain 3 electrons. Hey, look. Now we have a negative 3 charge. So these ones have a negative 3 charge. The next group is a negative 2. The next group is a negative 1. And the noble gases have a group of, or have a charge of 0. Okay? So what I would do, let's erase this extra stuff. But on a periodic table, whether it's the one that I gave you, you print off a different one, make sure that you have those written down for yourself, because that'll be very helpful. And let's label those charge of ions. All right? And then we will move on to some dot formulas. So again, this is more just kind of helping you out with bonding in general, okay? But dots show electrons in the outermost energy levels, aka it shows those valence electrons. And valence electrons want to be paired up. They want to have 4 groups of 2, so they want to have octets, right? So how we do this, and this will make more sense later, there's a reason why we do this, but it's just helping you to understand valence electrons. So calcium right here, if you look at your own periodic table, is in group number 2, okay? And group number 2 has 2 valence electrons. So I'm going to put 1 dot on that side and 1 dot on that side. It is one of my rules right here. Each side gets 1 dot before any gets 2 dots. Okay? So calcium, this is just another way to look at stuff. So calcium has 2 valence electrons. So remember, these things either want to have full or empty outer most valence electron shells, because if they empty out, then their next closest energy level would be full. So what's going to happen here is calcium closer to 0 valence electrons or 8 valence electrons, and it's closer to 0, so it's going to lose 2 electrons, and when it loses 2 electrons, it actually becomes a positive 2 charge, which is why calcium has a positive 2 charge. Carbon is in that group that has a 4 above it from the periodic table. If I go back a slide, it's right here. It has a 4 valence electrons. So again, each side gets 1 dot, for each side gets 2 dots. Okay. So is 4 closer to 0 or 8? It's kind of in the middle. It can do both. It can gain or lose. So it's a positive or a negative 4. Now chlorine is into our second to last group. It's a halogen. It has 7 valence electrons. So this is where 1, 2, 3, 4. There's 4 sides. 5, 6, 7. So there's 3 sides that have full pairs, and there's only 1. This 1 dot right here is by itself. So chlorine will only be able to make 1 bond later on. So what's going to happen here is it's going to gain, because it's really close to being 8 valence electrons, it's going to gain 1 electron, and it's going to have a negative 1 charge. And again, if you understood what I was saying before using the periodic table, this is just another way to explain why the valence electrons have to do with the charges. Lithium is in group number 1. It has 1 valence electron. It's going to lose it because it's closer to being empty than full, and it's going to have a +1 charge. Nitrogen is in the group next to carbon. It's in between carbon and oxygen. It's number 7 on your periodic table. It gets 5. So 1, 2, 3, 4. Every side gets 1 dot before any side gets 2, and I'm going to give this side 2. It doesn't matter which side you give 2 dots to. So it has 5 valence electrons. 5 is closer to 8 than 0. So it's going to gain 3 electrons, and it's going to have a -3 charge. Aluminum has 3. It's going to lose them because it's closer to 0 than 8, and it's going to have a +3 charge. Okay? Now you try magnesium, silicon, bromon, potassium, sodium, phosphorus, and boron, excuse me, and hopefully they match up to what I did up here. Silicon has the same as carbon. Chlorine and bromine look the same because they're all in the same groups. But you just give it a whirl. But again, this is just to kind of help you figure out why these charges are. But if you just trust, if you just write these things up here, that group 1 has 1 valence electron and 1 positive charge, and group 2 has 2 valence electron with a +2 charge, if you just trust in that, that is okay for now as well. So if you have any questions, make sure you email me, or you can do it on the daily check-in on the Google Classroom. The next lesson that I will post will be on ionic bonding.